Hey, Bdika. Can you hear us? Awesome. Okay. So I think we're almost ready to start. Okay. So hello, everyone, and welcome to another meetup of Web3 Devs Underground. We're really happy to see all of you here, physically and online. We'll start with our usual intro about our community, and then I would love to to say some words to Authentic, our lovely host here. So just an intro to first comers to our community. We're Web3 Devs Underground. We're a developers community. We're all we're all about open source and sharing knowledge and helping each other to learn and become better developers. Today, we're going to have a lecture with Leon, our dear community member and dear friend. So, in few words about our community, we were funded by Shauli Rejwan and Roy Yasherov around 3 or 4 years ago already. Time flies by. And everything started about sharing knowledge and not developing alone. I guess some of you are familiar with how it is to develop in Web3. And it can become a bit lonely sometimes, and even sharing best practices and stuff like that can be really, really hard sometimes. So this is how it started, friends sharing knowledge and helping each other become better. And through the years, we became bigger and bigger, and every month we would come together and meet physically to do events with developers from the community here in Israel. And things grew, and today we're doing online meetups worldwide and continuing our physical meetups every month. So thank you again for coming. And I would like to say a few words about our sponsor today, Masterkey Venture Capital. I will let the Authentic talk about themselves as well. So Masterkey Venture Capital is an early stage venture capital. We specialize in infrastructure and deep tech in the Web3 ecosystem. Team members are located around the globe, including 16 world-class cryptographers. That's it in general. And thank you so much, guys. And Dean, the mic is yours. Oh,
You have a smaller one, or this is the smallest?
this is the smallest one.
Okay, cool. Hey, guys. Awesome. Great hosting you. I'm Yarden. I'm one of the co-founders of Authentic Labs, which hosts this event today. So welcome to our sweet, cozy, and relatively new office. We've been here for, I think, 4 weeks. So happy to have you. Of course, we are always on board, taking opportunity to host Israeli community and contribute our part to the Israeli ecosystem. We are Tzabars, we are here to stay, and this is great to see the community flourish over time. And if we get a chance to, uplift to some extent this community, it's always a pleasure to do so. So Authentic Labs, we started off with Authentic Labs. It's an R&D company, of course, focused on the open web. We started our journey with a protocol called Authentic Stack, which is being used by 50 companies to date, fully in production, and it's an open protocol, self-serve, no touch. It's being used by companies such as Redstone, that tiered the largest Oracle to date. And for the past couple of months, we've been working on our second product. We call it Aleph, as you see. And our mission is to enable access to very sophisticated institutional grade product that currently is not available on chain. So we have seen the booming market of allocators and curators, for the one of you who know. Essentially, I, as a stablecoin allocator, can deposit my stablecoin to a more sophisticated manager to manage it and generate on-chain yield. Which is limited to between 4 to 9% yearly. Now, on the other end, we've seen regulated asset manager. We see the rise in the intersection of TradFi and DeFi, and we see institutional coming to our space, hopefully buying our bags. But they are completely limited and inaccessible to on-chain liquidity. And we see the rise of stablecoins, right? Today, there are more than 30 billion in stablecoin deposits across yield opportunity on chain, with outstanding supply of 300 stablecoin, and we see the rise in on-chain liquidity. So we've seen this market gap, and we decided, okay, somebody needs to build this infra that connects on-chain allocator with sophisticated asset managers. This is exactly our mission at Aleph. Our mission is to enable access to sophisticated institutional-grade yield product and access to asset managers currently unavailable on-chain. Thank you all for being here. And Leon?
Sure. Thank you. Ooh, can I increase it? Or leave it like that?
Perfect.
Okay. Okay, we can start. So I'm Leon. Thank you again for Web3 and Dev Underground to organizing the events, and thank you for everyone come to here, for attending, for hosting us. This lecture will be about ERC 804, basically a newly baked ERC about trustless agents released by the Ethereum community with consensus and Google. It was last month. I think just like this week it went to Cipolla, to the testnet. So right now it's in the testnet. I think next month it will basically going to be final version, and it's going to go to mainnet. Maybe cool. Okay, cool. So think about myself. So I like to call myself basically a crypto native playing with the AI. Before that, I was CTO of Fuse Network, was in L1 blockchain for DPoS chain with account abstraction. We built a stack for businesses and payments. Last year, I built like Ensemble. Ensemble is a coordination layer with AI agents. For AI agents, it's on chain. Basically, it enables you to discover AI agents and to pay to AI agents. And that's why I'm really like the standard. What ERC releases really speaks to what we are doing, what we did. It's like aligned with our vision. So that's why I wanted to do this lecture about the standard. So yeah, let's start. So what you will learn into this lecture? First of all, a bit introduction to AI, how AI works in general, what are tools, memory, etc., MCPs and A2A. A2A is really important concept for this standard because it's kind of like made for Ethereum. It was made for crypto, kind of for blockchain basically. And yeah, I'll touch about this in a while. Then ERC, then we dive into the standard and its trust more security and what you can build to the standard. Because when you look into the standard, it's really hard to imagine what you can really do with this and what can be done and what will be done actually. Okay, so let's start with AI agents. Maybe also place very small, like you can ask question. It can be like interactive. You can be really kind of use this basically. So who of you like built AI agent or used AI? Okay, yeah, I see you. Okay, so main components of AI agents, I like to see it as a human body. Let's look into AI agents as a human body. So you got the brain, it's like the LLM, and you got the hands the part is the tools of the AI agents. You can do search, APIs, use crypto wallet. So this slide was generated by the AI, so it got some mistakes here. And got prompts is basically the commands, and the context in window, long-term memory, basically the memory of the AI agent, what the agent memory remember, its context, etc., etc. So in this lecture, this gives more like explanation of this. So in this lecture, we want to touch about the tools of the AI agents, because all the standards focusing on tools. So tools is what agent can do, like accessing the calendar, accessing the mail, APIs. It's all done through tools. Anybody know how agents can use those tools? Basically, it's small definitions that it define and the LLM can discover which tool is more like basically, if I want to have a tool basically to search it for a token price, I want to search for a token price, and the agent got a tool to use CoinGecko, so he knows that he should use CoinGecko to look for the token price because it's part of the definition of the tool. It's kind of like parameter. Okay, you give a command to the agent, go to CoinGecko, use the CoinGecko API to get the token prices. And that's how the LLMs know how to use tools and go to services. So each tool have name, description, and parameters the agent can call. Yeah, and what's the difference between tools and just APIs? That's the difference. A agent can use APIs, but tools, basically, agents autonomously can decide which tools to use. That's that's the beauty, basically, about them. Then I want to touch a bit about the MCP, Model Context Protocol. It's a protocol that Anthropic, I think they released it a year ago. They released the MCP protocol. What's cool about MCP? It's like a server for AI agents. So if you think about tool as one endpoint, MCP is a bundle of tools around each topic. You got tools for MCP for file system, to access your file system. You got MCP for database to access database, and this kind of like packaging, and it makes discovering of tools more easy. Basically, a standard way to discover tool. Think of it of USB-C for AI. That's at least how the Anthropic team sells it. And that's like a standard how it works. We've got the MCP client that sends a JSON RPC command to the server, and server can access Slack and local file system on different stuff. Basically, here you have the credentials. Most of the time you run the MCP server, you run it on your computer, but you can also run it in the cloud. What's cool about MCP is it's actually useful. So not everything in crypto and AI is useful, and MCP is very useful. And that's why it was included in ERC 8004, basically. So the standard, I talk to you about MCP and A2A because they're both included in the standard. So just like, so here we go to the A2A protocol. It was released by Google about 6 months ago, around the time it was released by Google. Then it moved to the Linux Foundation. Now the Linux Foundation manages the protocol. So basically, it's for communication between agents. So how one agent can give a task to other agent, and its idea is around tasks. So it enables to discover, connect, and collaborate with other agents. It's more for the enterprises or centralized system. It's basically, for example, in Google, in the GCP, you got the agent space. So it really makes sense to integrate the A2A into the GCP. Basically. So in GCP, you can have like many Google agents or your agents. Okay, So why A2A matter? What's cool about A2A is that it enables interoperability between agents. You don't need to understand which language, which framework the agent is using, what is the framework. You can just send command to the agent and you communicate with different agents. And it's kind of built with the enterprise mindset, with a focus on authentication, privacy, and security. It was built basically to work with enterprises and to work with clouds for big companies. I know about like 50 companies. There are a foundation, about 50 companies in A2A. All the big companies are there. To be honest, not sure that everyone is really like using A2A. I'm not sure about how much is really used. MCP is used like 10x more than that A2A for sure. And one thing about A2A is it's more complex. So agent communication doesn't have so much use cases as just using tools. So how systems working today, AI systems, you got an agent and you send a command to the agent and he uses tools and he can use MCP. But when you got about A2A, let's look into it. Yes, basically the core actors in A2A is the human that sends he writes a prompt to the client to write the prompt, and the prompt goes to the client agent, and the client agent to basically to perform the prompt, the client agent can communicate with other agent. And the core component is about tasks. You can give tasks to other agents, and then you can see how are the tasks are performed. You can think about like as a smart task system for AI agents, basically. And all this speaks really close to what we're doing in Ensemble, and what we try to do is crypto in general, and that's why it was really, this standard was really picked up by Ethereum to do the standard. So what's also, so key components, as I said, you got the client, the AI agent that generates the command, you got the server that executes the command. They both communicate, like basically client send the task to the server, then server can update the tasks with push notifications. The client can check the status. It's kind of very advanced. The system here is pretty advanced for clients to communicate with server. So it really, if you think about agent collaboration, communication between two agents, it really solves a lot of issues, a lot of problems that may arise in this field. You could say tasks, and basically you can give tasks to the unit of work of the protocol is basically task. That's kind of like the unit of work of the protocol. I'm still not used about how much usage it got. Really not sure about the really usage of the protocol, but many big firms are pushing in it. And one very beautiful thing about the protocol is the agent card. And so I think that's what, at least when I was looking to the protocol and what's released, two things that what I was excited about is about the tasks, because our protocol had the same concept of tasks. And the second is agent card. Agent card is kind of like the agent ID. And when you got an agent ID, it really makes sense to put it on chain, put it in the blockchain. So that's the line of thought that I have about the protocol at least. So what is an agent card? It's the agent identity. It sits. So the protocol it's based on the HTTP. It's like Internet of Agents. It's really based on HTTP. It's not using blockchain at all. So you have the well-known location. You have the location that each domain. It's the A2A agent protocol / agent card.json. That's where the agent card sits. It describes what your agent can do and how to access with your agent, what are the capabilities, what's like the input, the output. Let's take into like real example. So that's a really simple example of the agent card. That's basically a weather forecast agent, an agent that can tell you the weather. And you have a description. You can access the agent on this address, and it's post streaming and push notifications. And then you have and skills is kind of like a tools that the agent has. And so by accessing by reading the agent card file, anyone can access and use the agent. So on your domain, .well-known / agent.json. So it's think about the browsers, the AI browsers. They're now so much common. So think about if AI browser will implement A2A. So you just go to the domain, and then the browser will find the AI agent in this domain, and you can talk with the agent in the browser.
So the domain and this specific path is kind of the new certificate?
It's a definition. Yeah, it's a definition. It's not a certificate. then yeah, it's the definition of the agent. It got all the capabilities of the agent, all the skills. It kind of like explains to you what the agent can do.
Yeah, just saying that like, domain takeover will allow me to change the code, right?
Exactly. Yeah. That's a good point. Yeah, there's security here. Yeah. Okay. Cool. So that's how the communication works in action. By the client agent send a task in JSON RPC to the remote agent. The agent can can communicate between them and ask more information. And the final response is basically the artifact. For example, to make like I can ask the agent, for example, I want to look for a property to rent, so I can ask client, I can ask the basic Airbnb agent, find me a property, or any rent agent, and then the remote agent will the Airbnb agent will ask more questions about which property I want, which property, how different some kind of like questions, what I call basically like a protocol, a part of a protocol to really understand to clarify the tasks basically. And then when he got all this, he can work and the response going to be an artifact with the list of properties. DeepMind team work on this. Part of the DeepMind team, they work on the same.
Investigation and authorization is out of scope?
In scope. Everything is part of the scope. You define like which type of authorization you want, define like security, you define like, think about enterprise. I'm enterprise, I want to use agent, I want to run it in remotely. So it gives you the all spec. And it was very cool because like we were building in Ensemble, we were building our own communication layer for all those things. And basically Google solves a big problem for us.
And there is any definition for the scope, like how many requests I can open, how many connections can be in the queue for both sides?
I'm not sure. It's not defined in the spec, I think. Maybe there's some limit if you think about security. So it should be run by the same party. What is second about A2A? It's like the client, it's the remote agent, they're belonging to the same organization. That I can say it should be belong for the same organization. Or yeah. But basically think about the client can be the user, but the client agent, it's kind of like, it sits on the server, so it runs by the organization. There should be a way to abuse it, of course, a lot of abuses in AI. It's a lot of work to cyber teams. All right, so AI vs MCP, what are the differences? So MCP is for tools, and it's more basically how I can extend the capabilities of my agent, while A2A, how I can give commands to other agents. And they're not really ones against each other. They basically work together. And here you can see a diagram how agents you can have the agent who got like MCP server. He can have a list of tools. And then with A2A protocol, you can talk with other agents. And so there's like black box agents. So meaning they can have a different architecture. This can be a LangChain agent. This can be a cloud agent. And what they showed here, that you have like one agent, black box agent 2, that's available both on A2A and both on MCP. Any questions till now? That's basically wrapping up the A2A part. Questions, feedback? Good. Okay, cool. So what we'll see in the future, basically, let's talk about the future. We got like, it's pretty cool. Agents can talk to other agents. Google were like pretty happy with the protocol. Not sure really happy, but yeah, it really solved their needs, let's say. But and many people were before that experimenting with agent networks and P protocol. There were different protocols like how to put agents on chain. And one challenge that is a trust, basically, how you can trust the agents you don't know, mainly, and that's how it's. So there was a kind of like as I said, that was a couple of blockchain protocols back in the day, like Virtuals, there is the ACP protocol to give tasks, on-chain tasks to agents. And a couple of months ago, also ERC 804 was born. It was really its first version. It was really like extension of A2A. It was working only with A2A. And what they did, they connected the agent card that we saw on chain. They connected the agent card to the block. They connected the A2A protocol have extensions, and you can have basically an ERC 804 extension to the A2A agents. So basically, A2A works well in trust environments, as I said. But now we want to build like basically the Internet of Agents. I think. Sorry. So yeah, so basically what we want to have is Internet of Agents. It's not like two agents talking with each other, but many agents communicating in a trustless way. So ERC try to solve three problems. Basically two problems: the discovery of agents and the trust between agents. And you can also have the payment rails you can connect it with X402, and that you have also the payment rails of the agents. So now we answered on two questions: how agents can discover each other and how agents can build trust. So ERC is a protocol to discover, choose, and interact with agents across organizational boundaries without trust to enable open agent economies. So, as I said, Internet of Agents. Basically, the big block is free registries. The free smart contracts that the agent is working is protocol is using is the identity, reputation, and validation. So okay, let's continue. So the first basically identity registry is how you start to communicate with the agents. It's starting from the identity registry. And identity is you need basically create like an on-chain identity to the agent. It got the metadata field, the JSON, so that connects to the A2A. Let's take a look how it looks. So that's basically the metadata of the agent. Here you got and this is pretty similar to A2A. You got kind of like the description of the agent. And you got the endpoints that you can access to use the agent. Here you got like the A2A endpoint, but you can also have the MCP endpoint. So the idea here, you got the identity registry with many agents inside this registry, and by reading this token URI that's basically part of the NFT. You can understand how to communicate with the agent and interact with it. Exactly. So this all like smart. There's like three main smart contracts. The identity registry. It's all about registries. All the standard is registries, and the registries. Even before the standard, people in the community were really like kind of like fed up with all those registries coming on, and then like Ethereum come and say, okay, that's the registries we want to use. That's the registries that we want. We want the identity registry to identify the agent, a reputation registry, and the validation registry. And I hopefully that will end the registry saga, because there's a lot of stuff to build, like, outside of registries. Registries are just like, think of this like anchors. Anchors for the agents are the registries. I wanna just make sure. Okay, so when you register an agent, you receive that NFT that makes you prove that you are the owner of the agent. It supports A2N MCP with the endpoint section. This basically this kind of like off-chain. They use kind of like IPFS to store the agent card, and you read the agent card, then you can understand how to communicate with the agent. And that's basically the bridge. That's basically the Web to Web3 bridge is the identity registry.
The identity registry is owned by, I mean, if I want to own my agent, I need to register it in my identity registry, or it's kind of a global registry that you just put your data in it?
Oh, that's a great question. So it's not like ERC 4331. It's not like a counter abstraction. You have like one gateway per blockchain. You can have many registries, and I guess they have many registries because they are not sure what you want to do with those registries. So they don't tell you you can have many registries. Basically, I need to tell you, the standard is pretty basic. We just like talking about registries, and you cannot do a lot of stuff with registries. That what I imagine is many people will need to build many stuff on top of those registries. So we can really have like agentic dApps on Ethereum. We can really need a little, indexing servers and validators and extend the smart contracts of the registries, and then you can have like agentic dApps. So what I believe will happen, that every team will have their own smart contracts, and there's gonna be the registry gonna be kind of like same language for different dApps to talk with each other. Think about like Uniswap and PancakeSwap, right? Two exchanges get different chains. So I believe that's gonna be happen with those registries. It's gonna be like dApps. It's not like a gateway, because you got like ERC 4331, that's count abstraction, that you got one registry per chain, and all the traffic goes through this registry. So here maybe in the future we will see it. Okay. So here basically you can see the registration, and here you have the registry address. So part of the agent card, that's the identity address. So the main methods of the registry is to register and mint NFT, and just to see the metadata of the registry, and you have events, and you can index it, and that's where the story ends for this one. Next is more interesting one is the reputation registry. So you can basically give reputations. Reputation gives score to the agent that was registered in the previous registry. Reputation registry receives the identity registry as a parameter, so he can reference it. Basically, it's about giving feedback to agents. Let's see. What's the main method? So basically, you can give feedback per agent, and basically you give a score to the agent. You can give two tags, for example, like task type and quality, and give a score, and some information, feedback URI. Basically, you can put a dog that proves, that gives like kind of a review. So this is basically a review system on chain for agents. That's what this is doing. And so you have the give feedback. You can remove feedback, and you can read feedback, get summary, and get clients.
ID, not the agent URL.
Yeah, the agent ID is the address of the address of the agent. Nice one. Yeah, that's a good question. You got a feedback URI here, which basically is the review. So you can think about, you go to the website, you use the agent, you really liked it, so you tap, I really like the agent, it was very good, it did what I wanted to do, and you give him a score, you press OK, and then the transaction goes on chain, and you write into the registry, and then every other users can see your review.
Yes, but it's not based on the reply that I got. I need to specify the agent ID. It means that I can provide the feedback for other agents.
So you mean basically I can provide to feedback that you don't
Yes.
authorization, basically you say? I think there's
That's my question. No, I'm not
okay, understood you. So that's basically the feedback, the auth, you get a signature that proves that you can authorize the review. I don't remember how it's implemented now, how they authorize it, but there's a authorization technique. Basically, it means like if you ordered a job for the agent, you can give a review to the agent. We can. Let's go back one. I just wanna. Okay, so we discussed about the registry with for feedback and giving scores. Blah blah blah. You can use APFS on Airwave to put the validation proofs and all the data. And yeah, it basically helps to discover like which agents are more qualified, which agents are more skilled. You can rate agents. You can order this. Then working. Okay. All right, cool. So next is the validation registry. It's for validate the task that you performed, and basically it like we can dive in. Let's dive next for the kind of trust model for the agent. That's the whole flow. Okay, so there's like free models that the agents can use for validation. You can just use reputation based. Basically, you can everyone can give a review for agent like Google. That's how you trust the agent. You can stake tokens to the agent. It basically can stake collateral, and that makes the agent more like trustful. Basically, the economic security model similar to validators, or you can use cryptographic trust model. That basically means running the agent into TEs, into trusted execution environment. For example, I know that's integrated with Fala. You know, Fala network is a TE network. So you can basically, that Fala network can be a validation layer for the agent, and they integrate it with the smart contracts of the standard. And then then they write to the contract, and the validation is governed by TEs. And for each use case, you should use a different. For your use case, you should choose which kind of validation you want. For example, if it's if we just want to order pizza, and it's not DeFi, it's not like a money operation. So in that sense, just a reputation base it's fine. In that case, you can just use a reputation model because the stakes are low. So if you talk to GPT, it's a reputation-based model is fine. You can just find the best agent. Then the mid model is I mean the low. Okay. So the next model is basically the staking model. For each model, you get a bit of more sensitive operations. not sure if operations that using money, maybe, but that like or operations that give like important data. You know, we have this model with the oracles, for example, with channeling users, staking model. So let's provide a similar solution for agents. So validators that verify the agents, they need to stake tokens, and with the tokens, they verify that the task was performed. They verify the agent. So you can that's basically and that's not part of the standards. Basically, the implementations you can do for the models. That's the example of economic validator when you can stake tokens and you can stake for validation basically. And then if you got minimum amount of tokens staked, in that case you can you can be a validator. You can be agent validator.
Like limited amount of payment.
So it's like, think about you want to validate agents, but to be a validator we need to trust you. So then you need to stake $1,000. Then when you put them in the contract, you can be a validator. But if you do a bad job, we take your money. That's in just the model of staking. So economic validators, that's example of implementation. It's not part of the standard. So you can define the validator with the minimum, with your stake amount, how much validators you have, some success rate, some parameters, and the function to stake for validation can be part of the smart contract. And the cryptographic verification, that's the most secured type of verification. It's basically the TE verifies your agent. In that model, you just run your agent in trust execution environment, and then the TE it verifies the agent. Okay, let's now think. Let's go back. So here an example of validation, how basically you can ask for to validate an agent. So the agent asks for validation request, and then the validator can approve, can make validate it basically, and only the agent owner can use and call that function. Here basically you can see the whole flow we discussed about the communication between between the agent, how the process is starting. So got the first of the everybody need to register. So both the client agent and the server agent, and here we take basically A2A. It's A2A with ERC 8004. Both of agents are registering to the registry. Then the client agents need to find the identity, find the server agent. So he looks in the identity registry. He looks for the agent card. When he finds the agent card, he uses the A2A protocol, and with A2A he assigns a task to the agent. That's kind of like A2A protocol, and then like here basically the server performs the task. So he asks for the validation. He asks the validation registry to perform the validation. And when the validation registry calls the validator agent, basically there's an event that the agent listens to, and he calls he can validate. Here basically he validates the tasks with cryptography or in any other way, and he throws the validation response. He basically calls the validation registry with the result of the the validation, and that means basically, let's say the task was successful and the validator agents approves the task, so the controller can signal to release the escrow, and the server agent can receive his money for the task. Yeah, part of it is also a reputation. I think here the feedback attestation is part of the reputation. Yeah. Okay, we did this. Any questions for?
Are there any actual use cases?
That's a great question. Yeah. So it's very new standard. So not much use cases of this. But I saw some. Yeah. Yeah.
Because actual, I think important if we look on agent, actual definition of agent, the actual not deterministic versus workflows where it's deterministic. When we speak about agents on chain, do we want this freedom of of activity, like, or we just speak about brackets about workflows, but now it's on chain, and we use reputation and registry of chain.
Awesome. Yeah. So let's touch about use cases in one moment. So benefits of the trust model, basically that you can choose your own model and it's flexible. It's because EF didn't know which model can work out and what really can work out. So they open it to different models, and every team can implement its own model. So the most use cases I see is there are around around infrastructure integration. For example, EigenDA integrated, sorry, EigenT, Eigen verifiable cloud integrated their verifiability solution into their registry. Basically, you can verify agents with EigenCloud. Fala Network did the same. So if we talk about like it's more easy to integrate infra, then it seems like it's much more easy to integrate infrastructure into this, but really make it useful for the real users to use agents. That's like what I saw the different use cases. That's what I find about this. Also, which use cases you really can build with the standard. So as I said, like every team can deploy its own contract. There's not like one contract for all. So I believe what we will see that we see like agentic dApps when every dApp deploys its own like smart contracts, all its own registries. They will add a lot of code, maybe extend the registries with own smart contract for rewards, their own NFTs, blah blah blah. And you can build like agentic dApps with this registries. So this use case that I saw basically about AI agent marketplaces. It's like obvious one because every agent got an identity. So you can fetch the agent, you can talk with the agent, you can rate the agent. So AI agent, kind of like the decentralized AI agent marketplaces can be a use case. A reward system for agents, basically give a reward for every agent on with the standard. I believe if you got like one registry, you get many registries, maybe you can have a reward system that integrates all of them. Maybe something similar to the King protocol we saw for incentives for DeFi. So I believe something like that going to be done for reputation-based agents. I know Zara team, they built kind of what they call agentic labor marketplace. It's basically looking into agents into workers, and they can verify the work that the agent did, and then the agent can get paid. What's the difference between AI marketplace and the labor market? You ask me. I don't know. I kid like labor market. It's a bit more advanced. Like you have your worker, you have your personality. Think about as hiring an external task force to do work for you. In theory, if we have like GPT-10, let's say we have like GPT-10 in 10 years, so GPT-10 is gonna be love the standard, and agents will love blockchain when they be really autonomous. Trustless collaboration. So a lot of one cool use case is about basically DeFi. If you take an agent TEE, and the agent can do a DeFi operations to you, do trading, some kind of like this kind of activity. So so through the standard you can access the agent, you can rate the agent, and basically it can be like a gushpanka for the agent because the agent is verified with the standard. It's like it can be like Uniswap. Right now the problem that before the standard every team needs to build their own infra, and then it's not so clear how the agents are secured, and this standard kind of solves it.
Who provides the TEE certificate?
So you basically got so you put the signatures, basically you can put them on chain, the certificates for the TEE, or you can access them basically.
But I need to do
What?
Execution is self-chain.
But it's on the TE, so you know what it's doing, right?
saying that it's run on the agent itself.
So you go to the registry, and that you got the signature here, and then by what is in the agent card, you can go to the TE and check that the agent is running there.
So I, as getting the reply, need to verify your answer with additional check of the TE that it really run.
Basically, the applications need to do this for you, and the application can check that. The application can check that it really runs on the TE, right?
Yeah, and skip.
Yeah. So, but basically, I know that Did you saw that the trading agents that was like really in the news this week, right? Did you know that like today all the agents lost money? You saw basically. They were good when the market was up, and then they were bad. I think only Grok and DeepSeek are okay. Almost. So what Eigen team did, they did the POC, and they did the same like exercise, but they were running the agents in the TEE, and then it's basically the use case here is agent vaults that you can you can put money to the smart contract, and then the agent can trade with this money. We can earn you profit, and then you trust the agent because it runs in the TEE, and ERC 804 provides all the info on the standard how to make it work. So basically to integrate it, and like ERC 721 for agents. So challenges, there's problem with Sybil attack, or basically anyone can read what he wants in the agent card. In the behind the scenes it could be something else. So no one claims it's really like bulletproof now, and there's a lot of work needed to make it bulletproof. The usability is a problem because there's no strong use cases for A2A, and of course, it's really hard. We all do blockchain. It's not how much it's hard for people to use blockchain. So now, when we want to agent use blockchain, it's add more frictions, and you should provide like a lot of value for doing this. maybe trading gonna be one of those values. Maybe it will work good with trading. So all the issue of incentives. You need to create incentives in the proper way, and if you don't, you have basic kind of like Oracle's problem, like channeling it when they were early in the days, and privacy. You need to balance the on-chain and off-chain, see how to do encryption, what you can expose or what you cannot expose. So some of the challenges got answers, but some of them just don't. All right, that's wrap of the talk. If you have any questions, you can ask now about the standard general.
The question, the new error code from Google from the API requires payment. It's not part of this spec.
Can you repeat the question for the audience?
Okay, so he asked about the X402 protocol. So this is the second presentation about this protocol. I can also do it if you like. But it's pretty cool. So it's much more useful. X402 is much more used than this protocol. It's in production and it's getting adopted by Google, by Vercel, by Cloudflare. Yeah. About this, okay, cool. Okay, thank you very much. Thank you for attending the lecture. Hope you understood. Hope it was fun. Awesome. Okay. בסדר, כי יש פה מעט אנשים, אז זה מביך יותר.
Everyone here,
Yeah.
we're friends anyways.
Yeah.
Okay, thank you so much, Leon. We'll take a few minutes break for making coffee or anything. If you want to take a few minutes. In the meantime, we have our usual part in the lecture where we ask you guys a few regular questions. So who here, even though it's a small audience, it makes it a bit more, I would say funny, but who here is an entrepreneur working in the space? So get your hand up. It will help us. Awesome. Is there anyone here looking for employees or let's start with looking for employees or looking to raise new developers or anything? Get your hand up. Awesome. Is there anyone here looking for work in the space or want to get into the space in any way? Get your hand up anyways. Awesome. Okay, great. So if there is anyone here who is first time comer to our lectures, first event, great to have you guys. Awesome. Okay, great. And and one last thing, if anyone here wants to say anything to the other members or the community at home, this is your chance. If you have a project, anything cool you want to share with the community or anything like that, this is your chance. We would love to hear you as well. So you can just come to the microphone and share it with our community. Awesome. So if there's anyone from home who want to do that, feel free to send us a message or a comment. I will add you to the stage and you can ask it for everyone. But in the meantime, we're going to take a few minute break and we'll be back in a few minutes. Thank you, guys. And we are back, guys.
And we are back to the second session about X402 protocol for payments. Before that, some news. So in the afternoon, preparing for the presentation, I was looking to X402 scan, and basically there's an explorer for X402 transactions, and in the morning it was down. Like the explorer did not work. I thought blockchain, it never works. It's all experimental. So, but then now it's working, and I understood why it did not work. They just was a huge spike of transactions happened just now. See, there was 10,000 percentage spike in amount of buyers. So before that they had like 1K of users. Now they have 30K, and they had basically nearly 2,000K of volume. And that all happens because one special, like that's basically servers. So X402 got servers that basically the buyers, so they sell services through the protocol. And the ping the ping server is generated, all the activity was generated by the ping server, which you can just buy pings with this. Okay, let's go back to the presentation, and I'm gonna to showcase this a bit later. So agent monetization, we discussed about trust and discovery in the previous session. Discuss how you can trust agents that you don't know, and how you can discover the agents. And now with this protocol, how you can basically pay to those agents, to the agents. And that's what X402 protocol is for. So let's see. Cool. So it's based on the 402 error code that was created with the internet. With the internet born, there was a special protocol for payment required. It was not used because PayPal got all the market, so they dumped the error code. And Coinbase basically now they do. It's basically the second attempt of Coinbase to revive the protocol. First attempt was a couple of years ago, before agents. It was just about the commerce. And now last year they did another revival of the protocol. I think they announced it a half year ago. It was announced in Denver. I think the first announcement of the protocol. So that's about how machines can pay. It's not about agents, but agents is the most important use case for this is basically agents. So as I said, basically right now, we want the thousands and billions of agents who will use the internet. And so we all see with ChatGPT now, you got apps, and you can give commands to agents, also like Figma agents and various agents, and those agents need to pay and need to get paid. They need to pay for services and get paid themselves, and this all can be done with X402 Rails. So what in the traditional system, in the traditional payments, what is like why it's hard for agents to use it? First, to use some API, you need to sign up to the API, which is hard for agents to do. You need to have like a billing account or a credit card and API keys, and then you can have API key, have authentication tokens, and with those you can use services. So that's like the process works for developers, it works for services. But if you want the agent to be autonomous, to use any service, you need something else. And that's what X402 solves for you. You can basically pay for anything in the web. You can pay with this protocol. It's basically a payment primitive. It's not related just for agents. Another Cloudflare, basically the X402 Foundation was formed last month, and Cloudflare, it was formed by Cloudflare and Coinbase. And Cloudflare is not a crypto company. it's an infra company. It's basically a web company. So as I understand, they have a problem with crawlers because many AI agents were crawling a lot of data, and they want to stop them from crawl the data. So I imagine going to be a use case to pay for crawling, and I imagine that the stablecoin that Cloudflare is releasing is also relates to this matter. But back to the protocol, so you can instant pay for anything, and you don't need verification. You don't need anything. You just send USDC, and you good to go. It also not support only crypto, by the way. You can just do this with credit card, with different options, with cash. No, you cannot do it with cash. Cash is not working. All right. So what's good about it's like an open chain agnostic protocol. It's even not for chains. It's for any payment networks to use this. So it's protocol native. It's part of from HTTP that Coinbase added a bit of options on top of it. It's what good about X402 that's really easy to use, and it's already integrated. Many companies integrate this protocol. It's integrated by Cloudflare. It's integrated by Vercel for MCPs, and it's not crypto companies. It's Web2 companies. Oh, I think that's already like a. So we see a usage here. So that's the ecosystem. I think it's for today. It is all the X402 ecosystem. So you have basically the wallets and payments. Coinbase base app support the protocol. If you know the new base app, you can pay to agents, pay for services using this protocol. We have ERC 804, of course. You have some chains here. So that's the interesting, basically, section. It's kind of like Web3 fintech companies that integrate the protocol, and of course, like the X402 scan of merit system, and somehow the big cloud companies that support. I know about the Cloudflare and Vercel support. I'm not sure how rest of the companies really support it. So let's do the payment flow. It's this. Oren, take a look. That's the payment flow. That's where you look for securities and problems and problems. So clients wants to go to the server and ask for go to some endpoints, and he receives 402 payment required error, and then and with this we select a couple of payment methods using the SDK the client can pay. For example, to generate a signature, like the standard method is to generate a signature that you approve USDC to be paid to the server, and then you decode this in X payment header. You decode the signature into the header. One of the headers, and then you send this you do again the request, but now you send to the with the signature. This one component, the facilitator. It's the entity who's like responsible to organize the protocol. Basically, he's verify the payments. It's kind of your bank. It's kind of like you have a Visa server. So this facilitator is the entity that basically submits the transaction chains, does settlements. So both the client and the server, they don't really need to care about blockchain. It's really agnostic to them how the payment is done, but they need to trust kind of the facilitator that facilitates the payment, basically. So the flow is that server receives the payload. He did not need to understand which kind of payload it is. He just sends it to the facilitator in the verify method, which performs the verification, and eventually the server sends the settle command. And the settle command sent the facilitator can look into the payload and submit the transaction on chain. For example, it submits the USDC transaction that sends the USDC from the client to the server, and this means when this blockchain like transaction is confirmed, it's settled, and then the client can finally use the endpoint and use it. So it's 12 steps, but it's much more simpler because the client have basically like two things he's doing, and most of the work is done by the facilitator. And can use blockchain, but it also can use Visa or other payment methods. So that's basically the server response. He got what it called the schema, like what's the payment, what's the payment conditions. So for example, it receives USDC on base mainnet, and it uses like 5 cents to use the endpoint and the address to pay. So that's part of the payload the server sends to the client. Now I'm going to show you how to integrate this endpoint in the buyer and in the seller. So let's say that's basically that's part of the Express service in Node.js, but it also can run in Python and in every language. So what you do, you just do a payment middleware, and you define which router you want to protect. And here you put the payment conditions, the price, the network, in that case. And here you put the facilitator you want to work with. Coinbase got their own facilitator, which is mostly used, but you also got some open source facilitator, the one facilitator that in Rust. So the seller integrates this into the backend. I think it can be done by, if you use Vercel, it can done automatically. And the beauty of it can work with MCPs, it can work with endpoint, it can work with MCP, it can work with tools, it can really work with everything. So what cool about this like all X402 thing, that it's not just for agents, it's for you work with every order that you're doing. Currency? It should be here. So price, you should have like basically the address of this. I think maybe the default is USDC. Maybe it's just the default. But I took this example from the docs, from the X402 docs. So how the buyer basically the client integrates, it's also this integrates in the front end of the thing, of the pay. Here you just need you got methods X402 fetch that it handles the payments for you. So here you have like fetch with payment, which are special methods that part of the library, and this method knows how to handle how to pay basically. So here like you do the transaction, and then it automatically can do the payment, and you have the payment response on the client side. So yes. So in this solution that they suggest us to do, the client sends the signature like USDC approve. You just say this the signature, it gives you access to send like 10 cents to this address, and the facilitator takes this transaction and puts it on chain. So yeah, gas is on the facilitator. That's why it cannot work for Ethereum on Ethereum network because it's slow and it's expensive. It's working much better on Base. On Base, it makes sense. Yeah. So right now, so that's a good question. I know the Coinbase run one good facilitator. I talked with one more guy who developed his own facilitator. There's like a splitter contract. There's a special smart contract to split the payments. So the facilitator, how they can basically have their own fee, cut their own fee, is to integrate the splitter contracts into the logic. So first, like you pay to a splitter contract, the contract gives like sends a fee for you, and the rest goes to the So this basically handled not by the protocol, but it can be handled by the smart contracts. So it can support more models how to pay. So the model that it's like right now, it's really focused on pay per use. Basically, what's cool about this, you do an image, you generate an image, and you pay immediately for the image generation. You open the website, you pay, you talk with a agent, and you immediately pay. It's really like you pay for each interaction. You pay and you pay and you pay, and which got its advantages but disadvantages as well. So it in theory it can do more models, can do like, we want that X402 will support like a tiered access, a subscription model, basically paying once a day, once a month. Probably like it will happen, but then like why you need the standard, maybe it can be done like in different way. So I think like pay per use, it's right now it's the killer feature of the protocol. So yeah, what's cool about this, like you don't, like before that I was doing a lot with payments, with crypto payments, and the problem was kind of like scale. Like you need to have like a payment gateway, and then all the payments it's handled in the payment gateway, and you don't integrate this into your protocol. So this basically X402 like solves this, because you got the Coinbase that pushes the protocol to many users, and you don't need really, and the facilitator handles all your crypto, as I said. So you just need to receive as I saw you, I remember the previous example, you got the buyer that receives a signature. It asks the facilitator to verify it, and yes, you need to trust the facilitator. I think it's similar how you trust your payment gateway, basically. And but you don't need to think about crypto. You don't need to handle crypto. Of course, it integrates pretty nice with all the Coinbase tech, with all the Coinbase infra, their smart accounts. They make it work really like seamlessly. So the integration is simple. The latency is low on fast chain. It's not so low on slow chains. It can work on every chain with cross-chain support, and it can be scalable. Right now, of course, it's not scalable. Right now, you do a transaction, you pay for every transaction. It's not scalable. It's not really scalable these days.
On the client side, do you need access to the wallet? Right?
Yeah.
You sign your part on the client, and facilitator also put it on the blockchain.
Yeah. So in the default example, you really sign the signature. You have your MetaMask open. You sign like, okay, I do access, and
I do programmatic.
yeah.
Talk about
Okay, so if it's agent, agent also can sign. Agents can sign, but for users, it's really not convenient to work with the protocol. For each request, I need to open MetaMask. I need to sign. but that's the action that people hate. People hate to open MetaMask. So the solution for this already developed. It's working with the count abstraction. So you have like the debt creates a wallet for you. You need to deposit to the wallet, and then the wallet it signs for you. So you don't need to sign. It transfers it's with for any request of funds. So basically Quest Flow is one of the leaders in have the base debt. I can showcase you them. I can show you how it works after that. Question? No? Okay, cool. Yeah, so that's about facilitators as payment routers. They do verification and do settlement, so the buyer and don't need to think about the blockchain. So what is unlocks like agent commerce to totems? So that's basically it's good also like for buyers as agents and sellers as agents, because seller can use any endpoint without permissions, just with the wallet. And it's also like I can also build an MCP, for example, and sell it for any other agents and users. So basically, I have an agent that's doing some service pretty well with this endpoint. So I can just upload it to the X4 to scan, and that's going to be discoverable by other users and agents, and that's how they can use it. So you can aggregate a lot of endpoints. Like you can do kind of like chats. You can select like I want to speak with those 3 agents, and they can work together on the command. Think of this as like more smart, like MCP gateways. Think about like MCP gateways that can create on the fly. For example, taking a ConGecko agent and take Nano Banana, and then I ask the agent to create draw me a chart of the prices. So the ConGecko agent will fetch the prices, and the Nano Banana can generate an image with the chart. So this way I have like many agents working together. Okay, so X42 it integrates pretty well with ERC 8004 that we talked about before the previous lecture, and the about A2A and X42 together. Not sure how they're really working. Not sure about this. So basically, but if let's really imagine a stack, an agentic stack, and I think many people are really building this. You can be basic ERC 8004 for identity and reputation. You do A2A to communicate with the agent, and X42 is built for payments. Think of it, when I started like coding, that was like the MERN stack, MongoDB, Express, all the stuff like React, and this can be the agentic stack for A2A, because on top of this you need LangChain and you need like Cloud. You really need to build the agent to make it useful. Okay, so what can the protocol can use for agents? Of course, like marketplaces. It's paid for any agents and more like economic autonomy. That's also nice, and that's about it for the start. And let me show you some demos, a couple of demos about this protocol. Yeah. So that's the new ping server. They just went bump today. You can see that it started to generate activity this week. So I can, that's basically the explorer of all X42 stuff. And I can do a ping for $1. So let's see how it works. No idea.
And it is it's connected to facilitator of Coinbase, right?
Yeah, exactly. You can hear you. Yeah.
I don't know if there are solutions for Lightning.
Lightning. I don't think so. No. Like I know there's one more facilitator that I know is okay. So Coinbase. You get third web that also built into this. It's like all validators. Like all BNB validators are CZ. So all the facilitators are Coinbase. Okay, you got like Pay AI. It's on Solana. So there was a team that was building the extension to Solana. And I know there's one more facilitator that in Rust. I think this one, there's one more implementation of the facilitator in Rust. Okay, I want to do just to show you just an example how it works. So let's try it out. So here I have a protected route. That's basically I went to the page. I did not pay it, so I have this like block. Then when I pay, I cannot pay. Yeah, I have to change an account. I can pay now. So I create a signature of USDC, and now I paid. I send the signature to the client and have a fund. So no email, no API, no anything. Okay, cool. Why? It's so one more example.
It's a new one. Yeah.
Okay, so let's look into QuestFlow. One more example of X42. So I can do the resources on this side, but it will not work very well because they use like queries, they use quiz. So you don't receive the response, you receive the ID. But here, how it can look in action, if it will work out. So here you have like a lot of agents, and all the agents connected with X42. So for example, like you can. Okay, cool. Yeah, okay. So here I can take to XBT, and I have here my wallet. So deposited here like 70 cents into the account. That's like a smart wallet. So you can see how's Bitcoin sentiment today. And then I pay just for this query, and I can use XBT. XBT costs like around $500 a month regularly, but with X402 I can just do a single query for it. So this should do. So it takes like maybe a minute, but eventually I will see here a response, and I see a log they did. If we look into history, so that's what I asked. Before that, something about prices, and cool. And that's basically was the payment. So see here I can see how each request, what was the price for each request. The pricing, like how they do the actual pricing. So I guess it's kind of like it's related to per tokens. I think it's pretty expensive, by the way, because I paid like a millicent, like for one chat. So yeah, it wasn't cheap. But yeah, it worked. Yeah, it cool. It's working. So you can, many people already building. You can have those agents which expose X402, and everyone can give them orders and request them. So that opens a bit of like a new type of dApps you can build, like this one, and you can do group chats with agents. You can do aggregations. You can basically maybe have the one answer, ask it to many agents, and aggregate the response. Yeah. Yeah, you do this. Yeah, you do this with models. So maybe like one agent can do it for you. I expect that many forms of delegation. So maybe if I trust you, I don't need to pay you for every request, right? I can pay you once in a while, once a month. Yeah, or maybe I can. Yeah. Exactly. Maybe I can give you like a reward tokens. So the next year we see a lot of. I expect a lot of cool things will build with the agent economy.
By the way, I'm not sure if it's a good question, but you said it's a bit expensive. Where does the inflated price come from? Like, what is expensive in this, or is it just like?
I think so. Basically, that's a good question. Between now, think about subscription model. It's basically a business question, right? Because you got a subscription model and you got like per request model. So if I have a service and I provide a subscription model for everyone, use like for 500 SXBT, you think it's cost like a couple of hundreds of dollars per month minimum to use it. But then I want to open for one query the service. So if I open this for anyone, so it can make some economic advantages for me. I should price it. So I would price like 10x more expensive in this month, and still it creates like very few revenues still right now.
I have another question. I'm not sure if it's even related, but maybe someone in the audience will also know to answer that. What languages are agents using to code today, and is there like better languages for agents to code in? Because like Python and stuff like that were built for humans, and it's really not as effective as it can be ideally, I would say. So are agents today using specific languages designed for agents? And if not, is it something people are working on today? Do you know?
Yeah, so that's a different question, but I know that agents very good in like LLMs, like it's a question about LLMs. LLMs are very good to predict the next character. That's why they're very good at encoding. So coding language, it's actually like simpler than human language. It's simpler. So that's why if the language it's very used, take like JavaScript and Python for example, there are many stuff written in JavaScript, or the internet in JavaScript. So that's why agents are good in coding in those languages, but they're worst in coding in Rust, for example, because not much code written in Rust. So I expect the agents will use the languages that you got a big corpus for them. So it's much easier for them to code than for us. It's just sloppy. The problem with them that it's the AI slop. They do too much. The code too much.
Is it realistic for agents to code in, let's say, assembly or like low-level language?
Yeah.
Just like, I don't know. We have a lot of code bases in assembly, even if it's
Not so many, not so much open source. Think about that. Every 10 years you got like 100x more code. So assembly, most of code was written like in the 90s, 70s, and it's written by banks, institutions, so many things. So this is really close source. So there's not enough examples in assembly for agents.
like the main driver is how much code is there.
Yes, but although like one optimization that I know like is happening, and no basically like Shlomo in base 44, what he did, that you don't need to code the whole thing. You can code like kind of like JSONs or optimizations, and based on these JSONs that the AI produces, you can generate the website, you can generate the code. It's also for transactions. If you don't want to do diff operations, you don't need to create the exact transaction. You can just get like a JSON saying to from this, and from this a code can generate a transaction.
Awesome. Thank you.
That's, something more about X402. No. Okay, cool. So thank you much for having this. So it was a really nice talk. Thank you, everyone here. Bye. Yalla.
Okay, so thank you everyone for joining us today. I would ask you to follow us on Twitter, LinkedIn, X, everything else, and see you at the next one. Thank you so much for everyone who joined us today, and see you at the next Web3 Devs Underground event.